Next, in question 6, in the very first question, the methyl carbanion attacks the double bond, and then the reaction proceeds as normal, and that gives us our alcohol. If it helps, what you can do for the first few times you're trying out this problem is that you can actually draw out the mechanism, and it really helps you visualize it better. Now let's compare example 1 and 2. The same thing happens where your carbanion attacks the carbon and pushes up the double bond to give the electrons to the oxygen. Except in the second question, now you have a good leaving group. So as always, the electron comes down, makes a double bond again, and pushes out this oxygen. And so you will have a carbonyl here once again, and then the Grignard reagent just comes back around and attacks the carbonyl, and then it pushes it up. And since now there's no leaving group to kick out, you're just going to have to protonate it using your workup step. And so that gives us this product right here. In the next reaction, notice that there is an alcohol, and remember what we discussed previously is that alcohols are strong enough to protonate our Grignard reagent. And so what you would get is a negatively charged oxygen and not the added alcohol that is desired from this reaction. So in the next step, you're given your final product. You're given a phenyl group attached to a phenyl group and then an alcohol. And so the way we go about doing this is to kind of work backwards. So we know that this alcohol was initially just an oxygen, so let's remove this H. We know that there is a double bond, and so we'll just put our imaginary double bond here, and then that gives you your carbonyl. Now let's look at our Grignard reagent, and right here you can see that the carbanion would be the phenyl group. So let's just remove the phenyl group from here, and then that would give us our starting reactant. So just to be clear, that's the phenyl group, the oxygen double bonded to a carbon, and then since there is only one carbon group attached to this carbonyl in the final product, we know that it is connected to a hydrogen. Alternatively, if there was an additional carbon group right here, then we would know that the initial product would have had a carbon here instead of the H. And for the last example, notice that the phenyl group is added twice, so that tells us that there is a good leaving group. We'll stick with our alkoxy, so our OME group. And so we'll just follow the same steps as we did before. We'll draw our linear carbon chain right here, and then we'll remove the hydrogen, move the electrons down to form a double bond, and we already know that one side is connected to the chain, and since it's a double addition of the phenyl groups, it's connected to a good leaving group, OME. And that's how we get a reactant from that reaction. Now we move on to question 7, where it asks us whether we can use PCC or Jones reagent for the following reactions. Now recall that this is a reaction of alcohol, specifically oxidation. The only situation in which PCC or Jones reagent really matters is in our primary alcohols. So recall that PCC only has the strength to give us an aldehyde out of a primary alcohol, while Jones reagent oxidizes all the way to a carboxylic acid. For secondary alcohols, on the other hand, you could use either reactions to give you a ketone. And recall that tertiary alcohols cannot react with either PCC or Jones reagent. So now let's go through the questions. The very first question gives us a secondary alcohol. So we know immediately that either the PCC or Jones reagent work in this case. Both the second and third question give us a primary alcohol. However, the second question gives us an aldehyde. And so in this case, we know it would be PCC. The third question gives us a carboxylic acid. And so we know that'll be a Jones reagent. Now for the next question, we have an alcohol that is connected to a benzene ring. And since that doesn't have any hydrogens attached to it, this cannot be oxidized. The other alcohol, on the other hand, is primary, and it gives us a carboxylic acid. And so we know that that's a Jones reagent. Finally, once again, we have a tertiary alcohol, which cannot react with either. And then we have a primary alcohol, which gives us a aldehyde on this side. And so we know that'll be PCC. Now, for our final question, you are asked to propose a synthesis for the following transformations. So initially, we are given a benzene ring connected to a carbon and then an alcohol group. And what we are asked to do is to add on this isopropyl group. Now, the way that I like to go about doing this question is to first look at what is added, and that is this group right here. So what do we know from this chapter that could add on a carbon chain? Our Grignard reagents. So what we need for a Grignard reagent would be a carbonyl. So the previous step we know for sure is a benzene ring with a aldehyde. And so I'll add the forward going arrow, and then I'll put in our Grignard reagent, H2O for workup, and then that would go from our quote unquote initial reactant to our final product. But the question is, how do we get from a primary alcohol to an aldehyde? Well, we had just discussed this. It would be the PCC. There you go. Now for this last reaction, what do we have that has changed? Well, it's the fact that there is the addition of two methyl groups, and then the fact that there is an alcohol right here. Now, we know that there's a good leaving group in the reactant, and so that explains a double addition. And where did we last see this? We saw it when we used our Grignard reagent. However, notice that there's an alcohol in the starting product, so the very first step you have to do before putting in the Grignard reagent is to put in your protecting group. And that gives us our TMSO. And then from then on, you can put in your Grignard reagent, and you know that you're adding a methyl group, so that'll be MEMGBr, and then our workup step. And so the reaction will go on as normal, and then you get TMSO, our benzene ring, our oxygen, our alcohol, and our two methyl groups. And then in order to deprotect our TMSO and give us back our alcohol, we just subject it to TBAF, and that gives us our final product.